Okay, so prime numbers. A number which has exactly, and I'm going to underline that, exactly 2 factors. And I'm going to underline the 2 because that's important. Now, primary school definition relates to the numbers 1 and itself, which is true, but you do really need to understand that it has to have exactly 2 factors. If you've got a great memory, feel free to learn them, but if not, it's all about a process of elimination. So start with the numbers 1, 2, 3, 4, 5, etc. and just go through and decide, well, do they meet the definition? So how many factors does 1 have? Well, 1 only has 1 factor itself. So it's only got 1 factor, so 1 cannot be prime. The number 2, it has 2 factors because 1 times 2, both 1 and 2 divide into 2, so it has exactly 2 factors, so it's a prime number, it meets the definition. 3, the numbers that divide into 3, 1 times 3, there are no other factors, 3 is also a prime number. Number 4, 1 times 4, but there are other factors, 2 times 2. Now, as long as I can find more than 2 factors, so it's got 1, 2, and 4, it cannot be a prime number. And in fact, 2 is very special. It is the only even prime number because every other number after that is going to have 2 as a factor, so they cannot be a prime number. Now, I'm not going to go through every single last one, but it is purely just a process of elimination. So if you had to check 5, is it prime? 1 times 5, yes, it's only got 2 factors. Carry the process on. 6, 1 times 6, 2 times 3, don't need to check anything else. It's got more than 2. No, it's not. And so on. So a typical question then could just literally be a list of numbers. Let's say you've got 15, 7, 18, and 21. You could be asked to find the prime number in the list of numbers. So use that method, think what the factors are. 1 times 15, I can see it's in the 5 times table. 3 times 5, it's not a prime number. 7, 1 times 7, 2 doesn't go, 3 doesn't go, it's looking prime. I'm going to leave it for now. 18, 1 and 18, it's even. 2 times 9, so straight away I can eliminate it. So it's between these two. 1 times 21, 2 doesn't go, 3s, check your 3s, 3 goes, 3 times 7, so it wasn't that one. So I was right to see that 7 was the prime number. And again, just remember, I didn't have to memorise them all. It's purely a process of, can I find any more factors other than 2? And if they have any more than 2, then you can eliminate them. If they only have 2, they're the prime.